I'd like to introduce you to Austin McKenna, who's a doctoral student in biological sciences in the School of Life Sciences, and his slam topic is A Tale of a Paradoxical Relationship, Starvation and Obesity.
Thank you for that introduction. So I want to talk to everybody today about an important health issue in America. Let me address that according to the CDC, roughly 36% of Americans are obese or will face obesity at some point in their lifetime. And obesity is one of the leading causes of death, either directly or indirectly. So with obesity comes a full suite of physiological consequences, ones that can lead to increased risk for diabetes, increased risk for cardiovascular disease, heart attack, and stroke. And we usually think about this health issue as a behavioral problem, one that can arise from increased eating coupled with a lack of physical activity, resulting in more fat store. But what if I were to tell you that some people are actually genetically predisposed to storing more fat? Let's pause for a second and look back at human evolutionary history. Ancient hominins and early modern humans were regularly confronted with starvation conditions while having to exert high levels of physical activity. As thus, it has been hypothesized that a mechanism evolved to store more fat to protect against possible starvation exposures. So it may be in our genetic architecture to store more fat. But how can we test that in the lab? We can't just take populations of people and starve them and the next generation. That's bad, okay? We aren't mad scientists. But what we can do is we can use a model system like flies. We can do this because A, they have short generations, so we can see evolutionary change, and B, they actually have a very similar genetic architecture to us. So what do? We take flies and we either put them through normal conditions where they always have access to food and reproduce, or we put them through starvation conditions for a certain amount of time, and the survivors are then allowed to reproduce. The next generations then go through the same selection protocols respectively. In just a few generations, we start to see physiological changes in our starvation-selected flies. We start to see increased fat stores in larval flies at earlier stages of life. Adult flies are storing up to 3 times more fat compared to control flies to survive starvation. With that being said, there has to be some genetic signature telling the organism to store fat this way. And that's where my project comes in. I'm looking for candidate genes responsible for increased fat store. So every generation, I'm going to be looking at the DNA and genes that are associated with increased fat. Let me finish by noting, if we can find candidate genes for obesity in flies, we can look for similar genes in humans, we can then identify populations of people at greater risk for obesity, we can then further nutritionally advise our community, and we can take a more comprehensive medical approach to treating obesity. Thank you.